Assalamu alaikum everyone. Today we are going to start chapter number 1 from book New Syllabus Mathematics D1. The chapter is prime, highest common factor and lowest common multiple. In this chapter we are going to read these three topics, which is prime numbers, the square root and cube root, highest common factor and lowest common factor. So let's start with the first topic, which is prime numbers. Here we have on page number 3 a recap is given. In primary school we have learned about factors. Factors means part of the number. For example 18, and we have to write the parts of 18, or we have to write in which tables 18 is multiplied, like 118, 18, 2 9s are 18, 3 6 are 18. So the factors of 18 are 1, 2, 3, 6, 9 and 18 as well. Notice that 18 is divisible by all its factor. If 18 is divided by each of its factor, there will not be any remainder. It means factor is that we divide a number without leaving any remainder. Here we have on the same page investigation, classification of whole numbers, find the factor of the number in table. So here we have different numbers and we have to find the factors of the number. So 1 is divisible by only 1, so the factor of 1 is 1. 2 is divisible by 2 and 1, so the factor is 1 and 2. 3, 1, 3. 4 is divisible by 1 and 2 and 4. So 1, 2, 4. 5, 1, 5. 6, 1, 2, 3 and 6. So on, we have to write the factors of the numbers 7, 8, 9, 10. And then we have to move on the next page. Here we have 11, 12, 13 until 20. We have to write all the factors of these numbers. 1, 2, 7, 14, 1, 3, 5, 15, 1, 2, 4, 8, 16. These all are the part of this 16. It means 6 is completely divided by these numbers without leaving any remainder. Now here we have classify the numbers in tables into 3 groups. From this table, group A contains number which is exactly divisible by one factor, so only 1 is divisible by one factor. Group B contains a number which is exactly 2 different factors. So in group 2 we have, group B we have 2 because it has 2 factor, 3, 5, 7, then we have 11, 13, 17 and 19. So these all are the numbers which are in group B with 2 different factors. Group C contains numbers with more than 2 different factors. So it means the remaining we have to write here. 1, 2, 3, 4, 5, 6, more than 2, more than 2, more than 2. So we have to write these numbers in this group C. Is 0 divisible by 1, 2, 3, 4? How many factors does 0 have? 0 has an indefinite numbers of factor. Here we have the definition of prime number. A prime number is whole number that has exactly 2 different factors, 1 and itself. It means only 2 factors are prime number. A composite number is a whole number that has more than 2 different factors. It means section B, group B is prime number and group C is composite number, because in group B we have only 2 factors, 1 and itself like 19, 1 and itself like 17, 1 and itself. And in group C we have more than 2 factors, like 20 we have 1, 2, 3, 4, 5, 6 factors. Like 18 we have 1, 2, 3, 4, 5, 6 factor. So group C is composite, group B is prime. Now here we have a question. Explain why 0 and 1 are neither prime and nor composite. So here we have the answer. Michael says that if a whole number is not prime, then it must be composite. Do you agree? Explain your answer. No, because 0 and 1 are neither prime nor composite. Page number 5. Again we have the investigation. Here we have some of the question, and according to these questions we have to solve this. In this part, the numbers which we circle are prime numbers and the numbers which will be crossed out are not prime number. So cross out 1. You have crossed circle 2. Cross out all the multiples of 2. So all the multiples of 2, 2, 4, 6, 8, 10, 12, 14, 16. Now cross out all the other multiples of 3. So we have to cross the multiple of 3. 3, 6, 9, 12, 15. Now circle the number next number that has not been crossed out. 5. Since 4 has been crossed out. So after 4 we have to start it from 5. We have to circle the number 5, 7, 11, 13, 17, 19. Cross out all the other multiples of 5. So the other multiples. After 5 we have to cross out other multiples. So 10, 15, 20, 30, 40, 50, 25, 35, 45. Repeat this process until the numbers has either been circled or crossed. It means we have to follow the same process, cut or circle the numbers. Then we have to solve this. Answer the following question. What is the smallest prime number? So the smallest prime number is 2. What is the largest prime number less than or equal to 100? So less than or equal to 100 is 97. How many prime numbers are less than or equal to 100? 25 numbers. You have to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 25. Is every odd number a prime number? Explain your answer. So here we have the explanation that no, not every odd number is a prime number, because 2, 3, 5, 7, 9, these all are prime numbers and odd numbers as well, except 2. So 2 prime number, 3 prime number, 5 prime number, 7 prime number, because these all numbers are having the factors 1 and itself. But 9 is an odd number but not a prime number, because it has more than 2 factors, 1, 3 and 9. So more than 2 factor means it is not a prime number. So every odd number is not a prime number. Question number E is every even number a composite number? Explain your answer. No, not every even number is a composite number, because 2, 4, 6, 8, 10, 2 is a even number, but it is not a composite number because 2 is having only 2 factors, 1 and 2. Composite numbers are those numbers which are having more than 2 factors, but 2 is having only 2 factors. 4 is having 1, 2 and 4. 6 is having 1, 2, 3 and 6. So composite numbers are more than 2 factors, but 2 is even number, but it has only 2 factors. Number F is, for a prime number greater than 5, what can the last digit be? Explain your answer. So here is the explanation, that if we take 0, 2, 4, 6 and 8, then it will be the multiple of 2. And if the multiple of 2, it means it is a composite number. If we take 0 and 5 in the last, it is also the multiple of 5. So it will also become the composite number. So to make a number, a prime number, we have to take the last digit 1, 3 or 7. So here we have to take the number greater than 5, it means we have to take 7. Here we have a journal writing. Can the product of two prime numbers be an odd number? Let's see. Yes, the product of two prime numbers like 3 and 5 is the odd number. 3 multiplied by 5 is 15. Product means when we multiply the number. If we multiply two prime numbers, the answer will be in the odd number. An even number. Can the product of two prime numbers be an even number? So the answer is yes. The product of two prime number, it means again if we multiply two prime numbers, the answer will also be in even numbers. Like if we multiply 2 multiplied by 3, the answer is 6, which is an even number. Number last is, can the product of two prime numbers be a prime numbers? So no, the product of two prime numbers P1 and P2 cannot be a prime number. We have take two prime numbers as P1 and P2 since P1 and P2 has at least 3 distance factor. So it is not a prime number. Page number 6. Here we have the solution. 47 is an odd number, so it is not divisible by 2. Since the numbers of the digit 47 is 4 plus 7, so the answer is 11. 47 is not divisible by 3. Now here we have the practice now 1. So we have to solve this practice now 1. Question number 1 is, are 537 and 59 prime number or composite number? So let's check. So to check the answer that whether it is a prime number or composite number, we have to use a method which is 537 is an odd number because the last digit is 7. So it is not divisible by 2, as we all know that odd number cannot be dividing by 2. First step, the sum of 537, it means we have to add all the numbers 537, which is 15, which is divisible by 3. So if the number is divisible by 3, it means it is not a prime number because prime number is having only 2 factors. So therefore 537 is a composite number because if we add 537, the answer is 15, which is divisible by 3. So the number is composite number. Again we have to follow the same method. 59 is an odd number because last digit is odd. So it is not divisible by 2. Odd number cannot be divided by 2. Now the sum of 5 and 9, it means we have to add both the numbers. 5 plus 9 is 14, which is not divisible by 3. 14 is not the divisible of 3. So it means that 59 is also not divisible by 5 because last digit is 9. Therefore it is a prime number. It means that 59 is having only one factor and it's self, so it is a prime number. Now according to this practice, we have question number 1 till A till D in exercise 1A. So let's move to exercise 1A. We have to solve the questions according to the practice. Here we have on page number 13 exercise 1A. Question number 1, same as it is as the practice we have done. Determine whether each of the following is a prime number or a composite number. So here we have 4 different numbers: 87, 67, 73, 91. So we have to find the number which is composite and which is prime. So let's solve. Here we have to solve this same as we have done in the practice now 1. 87. First we are going to check the number whether it is odd or even. So to check odd and even, we use to see the last number. It is 7, odd number. An odd number is not divisible by 2. The sum of 87 is 8 plus 7, 15. 15 is divisible by 3. So 87 is a composite number. Again 67, odd number which is not divisible by 2. Sum of 67 is 6 plus 7, 13, which is not divisible by 3. So the last digit is not 5 nor 0. So it is not divisible by 5. So it is a prime number. Same as it is, we have to check 73. Odd number not divisible by 2. Sum of 73 is 7 plus 3, 10, which is not divided by 3. The last digit is not 0 or not 5. So 73 is a prime number. 91, last digit is odd, which is not divisible by 2. Sum of 91 is 9 plus 1, 10, not divisible by 3. Last digit is not 5 nor 0, but 91 is divisible by 7. So it means it is a composite number. Let's see, 91 divided by 7. 7 1s are 7. 2 and 1. 7 3s are 21. So it means it is a composite number. To check the prime numbers, we can directly divide the numbers with these prime numbers to find that the number is composite or prime. 2, 3, 5, 7, 11. So as we can see that 7 and 91 can be divided. 2, 3, 5, 7, 11. Question number 2. In this game, a policeman is chasing a thief. The policeman can only step on tiles with prime numbers. Shaded the tile to trace the route that can make to catch the thief. So here I have colored all the tiles which are in prime numbers so that the policeman can easily catch the thief. Here we have exercise 1A, question 1, A till D, similar with this. So we have already done this. Now move on to practice 2. Here we have index notation. What is index notation? Index notation is what happens if we have 1, 2, 3, 4, 4, 5. We can write this 4, 5 as 5 and 4. Read as 5 to the power of 4. Where 4 is called the index, 5 is called the index notation. So it means here we have 1, 2, 3, 4, 5, 6, 7, 8. 3 and 8. So this is called the index notation, in which we have to write the power to the number. Here we have question number 1 in practice 2 now. If P and Q are whole number such that P multiplied by Q is 31, find the value of P plus Q and explain your answer. So if 31 is a prime number with only two factors 1 and 31, so we take 1 and 31 as P 1 and Q 31. So P is 1 and Q is 31. 31 plus 1 is 32. Number 2 is, if n is a whole number such that n multiplied by n plus 28 is a prime number, find the prime number, explain your answer. So let's find n multiplied by n plus 28 is a prime number, then n and n plus 28 are its only two factor, means n is the complete factor, complete prime number, and n plus 28 is a factor. Since 1 has to be one of its factor, it means 28 is already given, so it means n should be 1. If n is having only two factors, then n is equals to 1. Now we have to arrange the numbers in this equation, so we are going to put 1 instead of n. N multiply n plus 28. 1 multiply 1 plus 28. So 1, 28 plus 1 is 29. 29 multiplied by 1 is 29. The related questions from practice now 2 is exercise 1A, question number 11 and 12. So let's see question number 11 and 12. We are going to solve the exercise with the practice so we can easily understand the questions. Here we have question number 11. If P and q are whole numbers such that px is equals to 37. Find the value of p plus q. Explain your answer. This question is same as we have done in practice 2. Question number 1. So let's see. If you understand the practice work completely, you can easily solve the exercise. So 37 is a prime number. Factors of 37 is 1 and 37. We only want to find the value of p plus q. So it means p is 1, q is 37. 37 plus 1 is 38. Question number 12. If n is a whole number such that n multiply n plus 1 plus 42 is a prime number. Find the prime number. Explain your answer. This question is also same as we have done the practice 2 question. So here we have n multiply n plus 42 is a prime number. Then n plus 42 are its only two factors. It means that n should be 1 because 42 is already given. So in prime numbers we have only two factors, itself and 1. Since 1 has to be one of its two factor, then n is equals to 1. Now as we have already solved this type of question in the practice, now we are going to put the values. N multiply n plus 42, 1 multiply 1 plus 42. 1 plus 42 is 43. 1 multiplied by 43 is 43. Now here we have practice now 3. Find the prime factorizations of 126, leaving your answer in index notation. So let's find. Here we have to find the prime factorizations of 126. So this method is also LCM or prime factorization. We have to divide the number to write the answer. Here we have the prime factors of 126. 2 6 are 12, 2 3 are 6. Then we have 63, which is multiple of 3. 3 2s are 6, 3 1s are 3. Again 21 is also in the table of 3. 3 7s are 21. Now 7 1s are 7. So we have to write all these prime factors here. As you can see, these all numbers are prime numbers. Now 2 3 3 7, we have to write the answers in this notation. So to write the answer in this notation, we have to write the numbers in pair. 2 is only one number, 3 1 2. So we have write 3 here and 2 here as a power. It means we have 2 3 and then 7 same as it is. So this is the index notation answer. Question number 2 is express 539 as a product of its prime factor. So we have to write the prime factors of 539. 539 is 7 7s are 49, 4 here, again 7 7s are 49, 7 1s are 7, 7 1s are 7, then 11 1s are 11. Now we have the prime factors, which are 7 7 and 11. Now we have to write this in index notation. So we have 2 7s and 1 11. So this is the index notation answer. The questions related to practice 3 is question 2 A till D. These are the similar questions of this. So let's solve question number 2 A till D. Here we have question number 2. Find the prime factors of each of the following numbers, leaving your answer in index notation. Same as it is. 72, 187, 336, 630. So let's solve. What is index notation? Index notation means short way of writing a number being multiplied. Like 2 is multiplying 3 times. So we are going to write 2 as a base and 3 as an index or power of the number. Now here we have 72. We have two different methods. First is this and second we have done in the practice. So we can use any of the method. 2 2 3s are 6, 1 here, 2 6 are 12. 2 18s are 36, 2 9s are 18, 3 3s are 9, 3 1s are 3. Now we have to write all the factors, prime factors. These all numbers are prime. So the prime factors of 72 is 2, 2, 2, 3, 3. Now we have to write this in index notation. So we have total 1, 2, 3, 3, 2, and we have total 3, 2. So it means that the index notation is 2 power 3 multiply 3 power 2. So this is the index notation of 72. Same as it is we have done with 187, which is multiplied by 11 and then 17. So we don't have any index notation here because we don't have any same number in this question. 136, again we have to solve this 336 into this or this method. And then we are going to write the index notation, which is 2, 4, 3 and 7. 2 power 4, then 3 and then 7, because we have 1, 2, 3, 4. 630, again we have used the same prime factors method, and then we are going to write the index notation. Next topic is square root and cube root. So let's see practice 4. Here are the similar questions. Number 1 is find, this is called the square root. So find the square root by using prime factorization. Prime factorization means we have to use the prime numbers. So here we have the solution. As you can see, again we have two different methods to solve this question. Number 1 is this method and number 2 is this alternative method. So let's solve the question with both the methods. Here we have 784. So first we are going to solve this in this method. 2 3s are 6, 1 here, 2 9s are 18, 2 2s are 4, 2 1s are 2, 1 here, 2 9s are 18, 1 here, 2 6s are 12, 2 9s are 18, 1 here, 2 8s are 16, 2 4s are 8, 1 here, 2 9s are 18, 7 7s are 49, 7 1s are 7. Now here we have to write this in the square method. First we have to write all the prime factors 2, 2, 2, 2 and 7, 7. Now after this we have to separate both the numbers into two pairs, 1 2 3 4. So we have to take 2 here and 2 here, then 1 here and 1 here, so we can make both the pairs same. Now we can write this 2 multiply 7 is square. A square means we have the double of this value. As you can see, we have two values, so instead of writing these two values we just write square. It means we have the same double value. It means the square root of 784 is 2 multiply 7, and the answer is 28. 2 2s are 4, 4 7s are 28. Now we have the alternative method to solve this. So let's see what is the alternative method. In alternative method we simply have to write 784 pairs of 784 like this. After writing these pairs we are going to write 1 2 3 4 1 2. Now we have to write this into under root, square root. So the value of this square root is 2, so this 2 and this 2 should be cut, and this 4 and 2 should be cut, but we have 2 left. So 2 2s are 4 and 7, 4 7s are 28. Here I have solved this 7056 with the factors by using the same method. First you have to solve this in this method, so you can find the prime factors. After finding the prime factors you can solve this. So here 2 cut by 2, 2 and 2, 4 and 2, so the remaining is 2 upon 2, 3 and 7. 2 2s are 4, 3 7, 4 3s are 12. 12 multiplied by 7 is 84. Now we have the similar questions of this practice is exercise 1A, question 3A, B and question 4. So let's see. So here we have question number 3. Find each of the following by using prime factors. Question A and B, because these two questions are similar to practice 4. And then question number 4. It is also similar to practice 4. Question number A is square root 1764. So first we are going to write the prime factorization. Then we are going to write this into two different pairs. After writing the numbers into two pairs, we simply write a square here. 2, 3 and 7. 2 3s are 6, 6 7s are 42. It means that the square root of 1764 is 42. Here we have the alternative method, which is first we are going to write all the prime factors. Then we are going to write the index notation 2, 2 and 2. Then we are going to take this into under root 2 and 2, 2 and 2, 2 and 2, because the value of this under root is 2. Now the remaining numbers are 2, 3, 7. 2 3s are 6, 6 7s are 42. Same as it is, we have to solve this question 576, the prime factors. Then we are going to write the answer here, and then we have to write the same method in the alternative section. Next question is question number 4, which is same as it is as this question. So let's see. Question number 4 is given that the prime factors of 9801 is, the prime factors are given. We just have to write the square root of this number without using a calculator. Here we have 9801. The given prime factors are 3, 4 and 11, 2. It means that 1, 2, 3, 4 and 1, 2. Now we have to take this into under root. We have to cut this and this with this. So the remaining of 4 is 2. 3 3s are 9 and then 11. 9 multiplied by 11 is 99. Practice number 5. Find cube root of 2744 by using prime factorization. Here you can see the example of prime factorization. Like we have the number, we have to solve this number like this, and then we have second option of alternative. Same as it is, we have done the square root method, we have to do the cube root method. So let's solve. Here we have 2744, this question. Here are the prime factors of this number. 2 1s are 2, 2 3s are 6, 1 here, 2 7s are 14, 2 2s are 4, 2 6 are 12, 1 here, 2 8s are 16, 1 here, 2 6 are 12, 2 3s are 6, 2 4s are 8, 2 3s are 6. Then we have an odd number, so we are going to solve this with 7. 7 4s are 28, and then 7 9s are 63, 7 7s are 49, 7 1s are 7. So we are going to write all these prime factors here. Then we have to make them into index notation. Like you can see 1 2 3, 2 upon 3, 1 2 3, 7 upon 3. So it means that we have 3 pairs of each number. We have 3 3 of each, and we have to take here 2 multiplied by 7, 2 7s are 14. We have to take only this one time. Same as it is in alternative method, we have to write the factors here. Then again we have to write this method. We have to solve this cube and cube root. Now we have to cut this with this cube. Cube square is having 2, but when we have 3 here, it means the value of this is 3. So we have to cut all these. The remaining numbers are 2 and 7. 2 7s are 14. Same as it is. Number 2 is, given that the prime factorization of 9261 is 3 cube 7 cube. When we have 3 on the upper side, we read this as a cube. Find cube root 9261 without using a calculator. It means we have to solve this without using a calculator. So here we have simply 3 cube 9261. Now we have to write this with the alternative method. 3 cube and then 3 cube 7 cube. Then we have to cut all the 3 because the value of this cube is 3. So the remaining numbers are 3 and 7. 3 7s are 21. It means the cube root of 9261 is 21. Here we have the related questions, similar questions from practice now is question number 3, C and D, and question number 5. So let's solve these questions. Question number 3, C and D, and question number 5. So question number 3 is cube root 3375, cube root 1728. Let's solve these two questions. Here we have, first we have to make the prime factors of this number. So we have to make the prime factors with 3 because the last digit is odd number. So we have to start with 3. 3 1s are 3, 3 1s are 3, 3 2s are 6, 1 here, 3 5s are 15. 3 3s are 9, the remaining numbers are 2. 3 7s are 21, 1 here, 3 5s are 15. 3 1s are 3, 3 2s are 6, 3 5s are 15. Then we have 5 2s are 10, 5 5s are 25, 5 5s are 25, 5 1s are 5. So these all are the factors of 3375. Now we have to separate this factor into 3 parts because we have cube. It means we have to make 3 different parts. So we have to take 3 different parts of this factors. First we are going to write all the numbers here. Then we have 1 2 3, 1 2 3. Then again 1 2 3, 1 2 3. So we have make 3 pairs of the factors. It means we have 1 2 3, 3 pairs of 3 and 5. 3 and 5, 3 pairs. So we are going to take only common 3 and 5. 3 5s are 15. Now we have the alternative method in which we have to write all the factors. Then write the factors into index notation 1 2 3, 1 2 3. Now we have to take this into cubic root. Then we have to cut all the numbers powers. The remaining numbers are 3 and 5. 3 5s are 15. Same as it is, we have to solve this question. Like we have to write the prime factors, then make the pairs, and then multiply the numbers. In alternative, we have to make the pairs in index notation, and then we have to write the answer. Here we have 6. So when we cut 6 and 3, the remaining number is 2. 3 2s are 6, 2 2s are 4, 4 3s are 12. Question number 5 is also related to the practice 5. Given that the prime factorization of 21,952 is 2, 6 and 7 upon 3. Find the under root, the cube root without using a calculator. So let's see. Here we simply have to write the given into cube root. Then we are going to cut the cube with the numbers 3 and 3. 3 1s are 3, 3 2s are 6. So it means the remaining number is 2. 2 2s are 4 and 7. 4 7s are 28. Practice now 6. Estimate the value of under root 123 and cubic root 123. It means we have to find the estimate value which is nearest or which is easily to solve. So let's find out the nearest value. So here we have square root 123. So the nearest value of square root 123 is 121. How we are going to find that the nearest value is 121? Let's check. We have 123, so we are going to start from the highest number. Like 4 4s are 16, 7 7s are 49, 10 10s are 100, 11 11s are 122, 12 12s are 144. So 11 and 11 is nearest, but with 11 and 11 the answer will be 121. It means that the nearest square of 123 is 121. So it is the estimate square root of 123. Same as it is, we have cube root of 123. Find the nearest cube. So the nearest cube, to find the nearest cube, we are going to use the same method. Here we are doing square, double numbers. Here we are doing cube, so we are using triple numbers. 4 4 and 4. So let's check. 4 multiply 4 is 64. When we multiply 5 3 times, 125. When we multiply 6 3 times, 216. So the nearest of 123 is 125. It means that the cube root of 123 is 125. And if we cut this, we have 3 and the answer is 5. Now we have to solve the similar questions of this practice. The questions are question number 6, A to D. All the 4 questions of number 6. Let's solve. Here we have all the squares. So we have to find the nearest estimate, which means nearest estimate is square root of 66 is 64. 8 8 is 64. Estimate square of 80 is 81, which is 9 9 is 81. Estimate cube root of 218 is 216. When we multiply 6 3 times, we have to check by multiplying the numbers again and again, so we can easily find the answer. So when we multiply 6 3 times, the nearest answer is 216. Here we have the nearest answer is 9 729. If we multiply 9 3 times, because we have a cube here. Here we have a square. This shape is a square, so we have to use the number 2 times. Here we have cube, so we have to use the number 3 times. Practice now 7. Use a calculator to evaluate each of the following, leaving your answer correct to 4 decimal places where necessary. So here we can use the calculator. Let's solve these 2 questions. Here we have question number 1, which is 23 square plus under root 2025 minus 7 cube. So let's solve by using the calculator. First we have to write 23 cube. It means we have 23 square. It means we have to multiply 23 2 times. 23 multiplied by 23 is 529. Here you can see. Next is we have to find the square root under root of 2025. So we have to write under root 2025. So the answer is 45. We have to write the same symbols. Now we have to find the cube of 7. It means we have to multiply 7 3 times. The answer is 343. Now we have to add both the numbers and then subtract the number from the answer. So 529 plus 45 is 574, and then 574 minus 343, so the answer is 231. Number B is 3 square 5 cube under root 20 and under root 2013. Cube root. Now the square of 3 is 9. Cube of 3 is 125. Under root of 20. Under root of 20 is 4.472. 4.47. Cube root of 2013 is, to find the cube root in scientific calculator, first we have to press the shift button, this, and then we have this x3. It means this is used to be a cube root. Here you can see 3. Now we have to write 2, 0, 1, 3 is equals to 12.62. 12.62. Now we have to multiply these two numbers, so the answer is 40.23. We have to subtract these two numbers, so the answer is 112.38. When we divide these two numbers, 40.23 divided by 112.38, so the answer is 0.3582. 4 decimal place, it means after the point we have 4 decimal numbers. Question number 2 is, the area of a square poster is 987. Find the parameter of the poster, leaving your answer correct to 1 decimal place. So let's see. The area is 987. We have to take the under root of 987. The under root of 987 is 31.42. Now we have to write the parameter. To find the parameter, we have to multiply the answer with 4, because we are going to find a parameter of a square, which is square poster. So a square is having 4 equal sides, so we multiply this number with 4, so the answer is 125.7, which is 1 decimal point. Now the related questions of this practice is question number 7 A to C and question number 8 and 9. So let's solve these questions. Here we have the questions. Using a calculator to evaluate each of the following, leaving your answer correct to 4 decimal place where necessary. We have already done this type of question. Here in practice 7, you can see. Question number 1 is 7 square minus under root 361 plus 21 cube. So let's see the solution. The square of 7 is 49. Under root of 361 is, let's solve with the calculator. The square of 7, it means we have to multiply 7 2 times. 7 multiply 7, so the answer is 49. Under root 361 is 19, and cube of 21 is, it means we have to multiply 21 3 times. 9261. Then we have to subtract these two numbers, then add the number, and we get the answer. Same as it is, we have to solve this question. First we have to take the under root of 555, then we have to take the square of 5, cube of 2, and then cube root of 222. Let's see the cube root of 222. To take the cube root, we have to press shift and then this x cube. You can see 222 is equals to 6.055. Here you can see 6.055. Then you have to add the numbers, then you have to multiply the number, then divide the number, and you will get the answer. Same as it is number 3. Under root 4 cube, cube root 4913. So first 4 3 is 64, and under root cube root of 4913 is, let's see, shift cube root 4913 is 17. Here you can see. Now you have to take the square because we have two squares here. So the square root of 81 is 9. Question number 8 is, the area of a square photo frame is 250 centimeter square. Find the parameter of photo frame, leaving your answer into one decimal place. We have already done this type of question. Length of the each side of frame is, first we are going to take the square root of 250. Let's see the square root of 250. Square 250. 15.81. Now we have to multiply this 15.81 with 4 because we have a square photo frame. So the square is having 4 sides. The answer is 63.2, one decimal place. Question number 9. The volume of a box in a shape of cube is 2197. Find the area of one side of the box. So here we have cube. So we have to take the number in the cube. Then we have to find the cube of 2197. The answer is 13. Now we have to find the area. To find the area, we square the number 13 square. So the square of 13 is 169. When we multiply 13 two times, 13 multiply 13. So the answer is 169. Practice 9. Last practice of work exercise 1A. Are the year 2013 and 2017 prime numbers? So let's see. And the related questions of this exercise practice is 10A to D. The last question of exercise 1A. Here we have practice 8, 2013. If we take the square root, the answer is this. We have to take the nearest of 44.9. So the nearest of 44.9 is 43. Because these numbers are in square. So first we have to take the square, then check the number 2013. Last digit is odd, not divisible by 2. Sum of 2013 is 6, which is divisible by 3. It means 2013 is a composite number. We are going to solve this with the same method we have done in question number 1, but we just have to take the square root first. Same as it is, we have to take the square of 2017. So the largest prime number less than or equal than 2017 is 43 because it is 44. 2017, last digit is odd, not divisible by 2. Sum is 10, not divisible by 3. Therefore 2017 is a prime number. So let's solve the remaining related questions of this exercise A to D, question number 10. Here first I have written all the prime numbers till 29, 2, 3, 5, 7, 11, 13, 17, 19, 23, 29. So let's see. Odd number not divisible by 2, last digit. Sum is 19, not divisible by 3, last digit is neither 5 nor 0. But if we divide 6, 6, 7 with 23, so it is a composite number. We can divide the number exactly with the prime number, so we can get the answer. Same as it is 677. It is a prime number. 221. It is a composite number because it is divisible by 43. 2027. It is a prime number because it is not divisible by any other number by itself and 1. So this is the complete explanation of your chapter 1, exercise 1A. Hope you guys like it. Don't forget to like, share and subscribe. Thank you.